Another option is to run, of course, the rolling schema upgrades. So this is, as I said, this is a process of executing the change from the bottom to the top of the replication chain. So we are going slave by slave, one by one, implementing the schema change. And then at some point we fail over to one of those slaves, and finally we execute it on the master. The problem here is that schema changes have to be compatible, and they have to be compatible in terms of the application and reads, because during this process you will be, reading from slaves. Some of them may still have old schema, some of them may have already new. Therefore, your application has to be able to handle this. But also the problem is from the point of the replication itself, because MySQL replication has some limitations in terms of what kind of schema incompatibilities can exist, and it depends on what kind of binary log format you are using. So the best, the most, the best. I think the most popular, well, maybe not most popular, but the recommended way of setting up your application is using the role-based replication, and because it makes it will keep the consistency in the best way among the other options. But the problem with the role-based replication is that it's very strict in terms of what kind of differences can be in the schemas. So, for example, you can't add a column into the middle of the table. You have to add it at the end. You can't alter integer column into varchar column, for example. And there are many other limitations. So you have to be really cautious here when performing this kind of change. Okay, let's check our job. I think it should have, yes, it finished. So successfully added node. Okay, so as you can see, MySQL has been installed on the node that we pointed it to, and then as you can see, the extra backup has been executed to move data from the master to the slave. Once extra backup finished, replication has been configured, the grants has been created, and that's basically it. And the problem, the problem here for now with the MaxScale is that as of now it has limitation that it has to be restarted in order to see new hosts. So we need to go to our MaxScale node. If we list our servers, you will see that it still see only the master. So despite cluster control set it up everything in the configuration file, it's not possible to reload it. So we are going to stop it, and then we will start it again. This particular limitation, from what I've learned, will be removed in one of the next MaxScale versions, I believe 1.4. It's hard to tell when it will be released, but it's in the progress. Okay, let's start this. Okay, so we restarted the server, the MaxScale, and as you can see, we have our master point 62, and we have our slave detected at point 172. So that's basically it. So what is great with MaxScale is that if we start writing to this read-write speed port, the queries will be routed to master and to slave depending on what type of the query is. Let's try one more thing. Let's try maybe that we want to promote our slave. So what we can do is go to the nodes tab, go to the slave host, and basically execute the promote slave. job. So yeah, we are sure that we want to promote. Yes, we want to proceed, and we are going to check it because it should work pretty quick. So as you can see, some grants are being executed to ensure that the replication can be set up afterwards. We are waiting a little while for queries to terminate, so we don't kill the transactions. And then basically the whole of the process that is required is being performed by the cluster control. So the change master, so the changes in the grants, operations on the slave on the master to reslave it. So that's basically it. As you can see, it's pretty easy and pretty quick process. So what we can do right now, let's see how our MaxScale reacts. These servers execute, and as you can see, 0.62 was a master. Right now it's detecting as a slave. 0.170 was a slave. Right now it's detected as a master. Well, as it should be, right? Because that's basically what we want, what we just did. So let's try one more thing now. Let's say that our slave is for some reason we found it's not consistent with the master, and for some reason we determined it's the best way of handling the situation is to rebuild a node. So you can do it manually, of course, but we can do it from the cluster control. So when we go to our slave in the nodes tab, we can see stage replication slave job. And this job will basically do what we want. So we are going to rebuild the slave using the data from our master, and this is what is going to happen. So MySQL server will be stopped on the slave. The content of the data will be removed. The backup will be streamed from the master to the slave using extra backup, and then slave will be started. So we're going to proceed with this job, and okay, and basically MySQL is getting stopped on this node. So in the meantime, let's take a look at our metrics, our information about the status. So as I showed before, there was a master nodes section. Right now our master is 0.170. You can see the server ID, you can see its role, you can see the status online and functioning. You can check execute a GTID set, check binary log positions, and if there are any features for the binary logs, you can see it also here. So basically, it's just the whole replication status, replication related status of this host. And then we can see our slave nodes. Yes, so our slave 0.62. Again, server ID. We can see that something is not right here, and the status is that it can't be cluster control can't connect to MySQL server on this host. This is expected because we are rebuilding it right now, so that's perfectly fine. We have information about the master. We have information about the lag, how badly the node is lagging. Again, master log file, binary log positions, retrieved GTID set, and executed GTID set. So again, very deep, any data you may need to when handling with the replication. So in terms of hosts, host tabs you can see common pattern and common data like CPU utilization, load average, data bar network transmission, disk throughput, uptime, this kind of stuff. Of course, what else you can see here is that the cluster load section, you can check connections, selects, updates, this kind of metrics. You can see the query performance. So right now this cluster is not doing much, so there's not much. The graphs are not beautiful. But you can check the type of the selects, type of the joins. Very, I would say, common things to check when dealing with MySQL in general. DB-disk.io, reads, writes, and of course, and the handler tab is also available. It's just yes, and the information about what type of traffic you are seeing. And of course, in the notes, in the notes tab, you can check. Yeah, okay. It's just lagging a little bit. So in the notes tab, you can check and take a look at the standard data about the performance in general. So the CPU utilization, memory utilization, this kind of data. Okay, I think this is, yeah, notes tab, come on. I think I may need to, I will try to open another connection here. Yeah, all right, so we can see on each of the nodes, we can see the CPU utilization, network utilization, information about disk space, RAM, disk usage in terms of reads and writes per second, also in terms of the throughput. So that's basically it. Very common, I would say, data, but very useful when we are talking about, handling the MySQL in general and also MySQL replication. Okay, so our logs show that the node, that the job finished. So let's check if it's available now. Okay, looks fine here. In the cluster overview, slave is also available. It's in a correct state, so everything is set. As you can see, it's pretty easy to perform those operations from the cluster control. Just point, click, and this is really nice way to manage your replication topology. So if you like to try and see how it works, then you can just reach our webpage and download the cluster control, and basically using the cluster control deploy the whole topology like we just did today. So that would be it in terms of the cluster control, and let's go back to our slide deck. So we just discussed the rolling schema upgrades, and let's talk about PTONI schema change, which is the part of the Percona toolkit. So in short, this is a tool creates a new table with desired schema. It sets up triggers on the old table, which will kind of mirror the changes to the new table. And there is a background job using low priority inserts that copies the data from the original table to the new one. Once the process is done, the data has been copied. And once the process is done, the data has been copied, and then the rename table happens.